Hello, hi guys. Hi there, I'm Roberta. I'm talking today about this topic that I like in this period of my working life. I'm talking about JSON and SQL. JSON and SQL Database. SQL Database is the name of the service in Azure that stands for a sort of SQL server managed and completely platform as a service. Okay, so it's not a session about the platform, the service itself, but the integration between JSON and the relational database like SQL. Okay, thanks to the organizers of the Code Gen. Thanks to Andrea for organizing this amazing event. Thanks to Marco that is helping me to delivering this session. And let's start. So this session is not a contest, and there's no winner between relational and NoSQL in my mind. There's the future, the present, and the future. In my opinion, is the integration. It's been represented by the integration between the two words. Okay, so relational is great. I love tables. I love foreign keys. I love transaction. I love all the stuff that is tied to the relational word. But I also love NoSQL for some features that I used a lot in the last almost 10 years, probably. So, for instance, I worked in an e-commerce company, and 99% of all the traffic of the web traffic was NoSQL. So it was like a search service, like Elasticsearch, like in the specific was Azure Search. But I also use blobs, files, just to store unstructured documents. And now there's the common buzzword of data lakes everywhere, but I really like them in order to store large blobs of data that are not in the final data store itself. So I really believe that the future and the present is being represented by this if-type integration between relational and NoSQL. So let's keep a simple sample of what kind of integration we are going to see today. Okay, so let's think about data coming from JSON or multiple JSONs. Okay, like from colleagues from the data science team, for instance. So they provide with us some input files that probably are the outputs of some computing somewhere. Okay. So we probably need to clean that input and to engineer some data store to hold that data. So for instance, create some tables to hold that data in the relational database. And then we start to ingest that data, for instance, with some manual approach or some integration approach, like in Azure, there's a tool called Data Factory, but we also can use SQL Server integration services, just a console application, just scripts. So we can use a lot of options to integrate, to ingest the data inside the relational database, okay, to provide something that is an aggregation, so something like a view, something like a final data sync where the consumers are taking that data to deliver their results, okay, like in a BI platform. So there's a common issue in that scenario, the fact that incoming data may change. So when the data is JSON or CSV or something like that, okay, we can notice a change in that data. So some of you can also say, okay, but usually in integration in there's a contract. Okay, so there's a contract between the producer and the consumer. So you can just break the contract and produce different data from what the consumer is expecting. Okay, but it's not always true. It's not always true, and often it's not the fault of the producer engine, but just the requirement that change. Okay, so if the requirement change, for instance, by adding new entities to the output model, or just new fields in the single entity, or missing field, or some fields that are different in terms of semantic, you should change something in this pipeline. So for instance, the cleaning process or the engineering of the tables. Okay, so let's take an example. If we have the person table, so with the first name, last name, and at some point of time, also the birth date arrives, we need to add a new field in the database to hold that kind of property. Okay, it's not a huge issue. Okay, we know, but I have an approach. I have an alternative approach that can be effective in that kind of situation. Today, the scenario we are going to see is a simple scenario where two different files come into our system. One is the movie JSON with some movies taken from Kaggle, and a huge set of reviews of that movies also taken from Kaggle. Okay, from Kaggle. Okay, that two JSON can mix together to produce some consolidated views of a sort of big table where all the stuff can be consumed by a BI person or by someone that can just write this select star from that table to have the all results. Okay. So, well, get data. Where we get data, we got data here on Kaggle. The two files are movie details. One item is just the movie ID, the summary, duration, some general rating, release date, and so on. And the review file, that is quite huge for a JSON, okay, is composed by a huge number of items, like 500,000, and each one is the review text, if the review is a spoiler. So in the specific sample, this data set was probably intended to be a collection of reviews where some sort of artificial intelligence understood if a review is a spoiler or not. Okay, so but it's not the point of the section. Okay, so we have a lot of reviews, a lot of stuff, and each item is composed by these properties. Okay. First suggestion, when you need to handle with huge JSON, probably some conventional instrument like VS Code, Visual Studio, Notepad++ can block. Okay, so Notepad++, for example, doesn't open this kind of file. So I suggest you use this DeadWrite JSON viewer that I discovered just a few months ago, and this performs very well even with files like this one, that is 1 GB file of about 500,000 items. Okay, and in few seconds, I hope. Okay. We have this output, and we can also seek in the file. So it's a good browser of JSON file with this kind of interface that's very effective. Okay, so good. We got the data, so, and now we want to skip this part for the moment, okay, because in this specific sample, we just to be more fast, to be faster, we want to clean and ingest at the same time. So we need first to engineer the tables, and then we want to clean and ingest the data into the tables to produce the results. Okay, so let's engineer the table. Here we have some suggestion for you. The first is if you are already or you are going to work with a relational database and the complexity is growing up, you should use something like a management tool for the database engineering, so for the database design. I personally use for simple projects the Visual Studio and the database project. The database project is an artifact that can hold some artifacts typical of SQL Server, so views, tables, and the nice thing of this is that you just declare your entities and you can deploy your entities against the database. Not the all entities, but also some new field, for instance, okay, null. I'm just adding this new field here, just changing something, and with this strategy, I compare what is in place in this project with what is already deployed of the database. The tool detects the differences, and we can produce like a script that just perform the diff of the operation that are needed to align the database with the expected one. So in this case, we are detecting that in the local model, there's a new field, in the remote model, there isn't, and we can produce a script that is just altering the database with a new field. Okay, this is a powerful approach to database design because everything is versioned in Git, okay? And when you make some changes, you are just producing the script that goes in the specific of your editing. There are a lot of tools like this. So if you are a database engineer, probably you use Redgate tools from years. Okay, so I'm not telling you that this is the best approach or the only approach. I'm just telling you if you are going or you are already engineering database, you should use some sort of integrated tool to do that instead of just using SQL Server Management Studio or just the MySQL Workbench or something like that. Okay. Good. So in that case, we can undo this change and let's go inside the database design. Okay, in this case, we here, just a second, hold on. Okay, we have a movie with movie ID. We guessed the varchar 20. So this is one of the first issue. Okay, we don't know actually if 20 is a good enough for this ID, but let's suppose that's in the contract there's this requirement. Okay, so let's take for good this varchar 20. We also create all the other fields like plus summary, that is max, because we don't know the length, the total length of this field. Duration is time, so we need to find out a way to convert this stuff to a time, okay? The same thing for rating, that here is represented by a string, but we want a decimal, and the date that here just simpler than the duration, but it's a notation in string, and we want a date, of course. Okay, the same stands for reviews, but there is a little bit of surrogate field here, because in the reviews we don't have wait, amen. Okay, we don't have a review ID. Okay, why? It doesn't matter why. Actually, the issue is that we have the input without a review ID, but it's really better in the relational database to have a primary key. Also, to connect the review to the not really, just to for performance reason, for to avoid to have also the cluster index associated to the primary key. So it's better to have the primary key, and so we have to introduce a new field that is not really needed. Okay, so it's not a part of the input mode. It's not really needed, and it's just introduced by ourselves to have some sort of identity for the primary key of unique value. Okay. We have the review date. Okay, this one is a good point because it's the movie ID, and we want to enforce the foreign key reference to the other table. Okay, let's see that if in the database project we write something like that, the project won't build anymore. Okay, because this is another favor that comes in for us. The compilation of the database projects is not really a compilation, of course, but the process of build also checks all this kind of stuff. So you cannot have invalid SQL in your database project. That is really good. So let's come back to the foreign key. Okay, it's a good approach to have foreign key to enforce relational integrity, but we will see that this dataset, for instance, have some reviews that have a reference to a movie that is not present in the movies JSON. Okay, so this is one of the examples that I told at the beginning of this session. So it can happen that you have some data set that should be consistent, should follow some sort of contract, but in fact, okay, it doesn't. So in that case, in my sample here, when I imported the data, I found out some reviews that had the reference, the good reference to an existing movie ID. So let's go ahead. We have simple stuff, and that's okay. So we engineered at the best we could the two tables that can host all this data. Well, let's go ahead. Now we can produce and ingest, first ingest and then produce the results. So let's see how to do that. Just to let you all the code, so all this code and the presentation is also on my GitHub, so everything that you see in this session is already available over there. Just to, for this reason, I wrote the integration code in C#. So probably in production, you have something like a job, something like a data factory pipeline, another kind of pipeline. In this case, we have C#. So in this code, we read the JSON, the movie JSON. We perform some sort of cleaning and processing. So in this case, I parse the duration into a time span. I serialize into a JSON array the genre. I convert to decimal. I convert to a date time. And I do this kind of stuff in C#, and I'm adding all the stuff into the database. I do the same with the reviews, also connecting the external reference to the movie. And the result is this one. So table for the movies and the table for the reviews. Okay, good. Now we can produce the results. So I can create a new view, for instance, taking movies and reviews. I'm using this designer to be faster in theory. Okay. Hey, my friend. Okay. Good. I'm taking, well, movie ID, all the stuff here. Here, just take the review ID, and those ones. Okay. Yeah. And now we have a view. Why I created this view? Because we have the relational model into the database, but always, often, the relational model is not the final model we want to expose to our internal or external customers. For instance, in our company, we do not involve complex operation or aggregation in the database itself, but in some sort of data warehouse from the BI team. Okay, so in that case, I'm producing a view that is the normalized version, so the join between the reviews and the movie. So you can expect multiple rows for a single movie. Each row is a review. Okay, this is a pretty simple query, so just it involves just this kind of join, so it's good enough. Okay, well, now we come to choice. Okay, if you need to change that rows, the individual rows, okay, for instance, by updating some values of the movies, of the reviews, by the database itself, or by some code, or if you need to perform aggregation, complex aggregation, okay, you should keep the tables probably. So you should keep the relational model, which the fields are created effectively by like in the create table, okay, in the create table statement. But if you have incoming data that is immutable because it comes from outside, that it's not designed to be updated, okay? And you need to just ingest and produce a sort of aggregation for your internal or external client. And you also know that this data is not really reliable in terms of consistency. You can avoid this approach of the relational tables and adopt JSON in column. Okay, it's the purpose of this session. Okay. So let's take two approach that I call hybrid and full JSON, but it's not really an a standard naming, just my way to call them. Okay, the hybrid approach is just a mix of relational and JSON. The full approach is just the most JSON we can inside the database. Okay, so let's see. Well. We have the hybrid mode. That is, let's look here in Visual Studio. The hybrid mode for the movies table is very similar to the previous table, but in addition to that, we have a varchar max with all the reviews. So this table is expected to hold the data of the movie in the relational format and the data of reviews in JSON. Okay, so for instance, we can go here, take some rows, just a few, okay, and we see that we have relational data and then this one, okay. So we want now to use the JSON functions of SQL to get data out of this, okay. So let's start from take just one item. So I do not use top one, you will see why. Just use a specific one. So movie ID, let's take the first or the third, this one. Okay. Okay, good. So let's take just two reviews. And now let's introduce an operation that is represented by the function openJSON. Okay, openJSON argument. I increase the text size. Okay. What does it do? Okay, is a function to open a JSON array and create a table, and with the lines represented by the rate items. So if you open JSON with a JSON array, you produce a data set, so a table with the number of rows equal to the number of items of that JSON. Okay, so we can say cross-apply the row of the result with this, okay, with this, and then select star. What we have right now, we have just the movie ID, the single movie ID. So I'm expecting to have it's really huge, this one. So probably it's better to take the first. Yeah, just a second, hold on. Blah. Okay. So for that movie, we have, let's see, 100 rows, so 100 reviews, okay? The movie is the same, and with this cross-apply, we create a new line for each item in the reviews, which fields the openJSON created, the field key, value, and type. So I can just select value to have just the single review item, okay, of this specific movie. And then I can start with some nice other feature of the JSON function of SQL. So JSON value, take value, and project the field review date as review date. Okay, now it's a string, but we want to parse it. Try parse it. Okay, so yeah, try parse. It's not C#. Try cast. Okay, JSON value as date as review date, and now it's a date. So let's go ahead. The second part, let me check here. That is quite common. It's movie ID. Okay, so let's go ahead faster. Movie ID as okay, good. Then we have user ID. That's very simple. We have is spoiler. That's a bool. Spoiler. So now try guess JSON value as bit. For you that you're asking, probably you're thinking how is performing this kind of conversion code and casting codes is very, very, very powerful. So it's something that stands in SQL for years from the beginning, and it's really very performant. You can also wrap all the stuff into some custom function, but it's better to use here because the planner is going to optimize that. Then we have the review text, review view text and the rating and the review summary. Review summary. Okay, the rating is a decimal of 3.1 because can be also 10.0. So 3.1 is because of that, and we probably are okay. Just the names are to be aligned. 1, 2, 3. This is not necessary anymore, and tada, we have all the stuff in a relational form. So we can take out this and we can create view. We can call it playground.reviews demo as okay. So now we have a view that is really behaving like a real view, like a real table. So from the consumer perspective, the BI team, the Power BI consumer, the Tableau consumer, the process that takes this stuff to produce an output for the data warehouse is seeing all the stuff as a relational database. So if we want to go inside the execution plan, we say it's quite good for us. Okay, of course, there's a function to open the JSON instead of just scanning the table and merging the results, but it's really effective in terms of performance. So we can do some sort of performance benchmarks, okay, and it's really good from that point of view. Okay. The second approach that I suggested, the full JSON. Okay, so we don't want anymore this kind of stuff. It's useless. Why should we take this fields if this is a valid approach? So the full JSON approach can be something like that. Okay, just a key for performance reason, or not really one, but also the relevant fields on which you want to put an index on, okay, and you can keep them as regular fields. Someone of you that already use JSON function could also think, okay, but we can also index the properties inside the JSON. Yes, we can. So if we have a movie and inside this document there's a single root document of JSON, we can put an index of in the specific properties of this root document. This is not valid if in the document we have an array. So in this example, we can put indexes of in fields that are inside this document, but not in this document, because this document is represented by an array of items in JSON, of course. Good. So in this approach, we have a simpler table, okay? Something like that. I'm not taking 1,000 items because of the bandwidth, because inside this column there's a lot of stuff. Okay, just take one, and we have the same approach. So why I'm performing the same thing right now? Because I'm introducing a new operation, a new function. Okay, so where movie ID. Let's take all the stuff. Okay, so let's take movie. We can take movie ID both from the outside table, but also from the inside JSON. We take the outside one. It's the same. So, and here we can start with the JSON value again, movie and plot summary. And whoa, okay, let's dig into the properties. Yeah, and the duration. Okay, let's see how to manage this kind of field. Okay, it seems tricky, but it's a really performant approach. We can say something like that. Okay, we have the duration. Let's see that duration of la. We can start by trimming all the stuff in case there's some space after or before. We can replace this with h space with column and this stuff with min with column 0, 0. Why? It's not really an elegant approach, but after that we can try-cast, try-cast this as a time, and since it's in the good format of time, it works. So we have duration. Duration can be aggregate, can be summed, can be calculated after by the consumer. So we can do this also with a function. I have a function here to do that. So here, function, a function here that converts a string to a time span. Okay, but I prefer to do this manually here for you for the demonstration purposes. Okay. After that, we have the genre. Oh, well, genre. Genre in the original table, where was something like here? We had this array, this JSON array. Okay, and we want to preserve this approach. So let's try to use JSON value movie genre. Okay, as genre. Okay, boom, null. Why? Because it's not a value. Okay, it's an array. So if I want a value, I should specify the index. And now it's okay, but now it's just a first. Okay, in that case comes in help a function that is not JSON value, but JSON query. So JSON query returns the row object of this leaf, of this expression. So in this case, it returns the object represented by genre. So in this case, returns the array itself. And it's okay. Let's go ahead. We have rating, so we can also copy and paste some stuff from here. Rating, and we have release date. Or release date. It's not value anymore. It's just movie. We can fix the names. And we finish. Oh, plot synopsis. Plot synopsis. Okay. And we have all the stuff. This is a blank because it's blank. Okay, so I tried this in the demo, but if we do this, okay, these are valid. So all the 1,500 rows are now materialized here, and they all come from a JSON inside this field. So you see that the performance are good, but it's not really a good metric because I'm with a good bandwidth, I'm in good conditions. Okay, I suggest you to perform your benchmark to take your evidences of this performance because they are really good. So now we can do the last step of this part. We can take this stuff, okay, go here and say cross apply open JSON reviews. So this will multiply all the rows with the cardinality of the review items. It opens the single JSON in a field name and value. So now I'm exposing all the fields from the value field into a specific field. In this case, there's a naming collision, so I can say review rating. Okay, and movie ID is not needed anymore because we already have here, and I think it's okay like this. So let's go with some format, and let's create a view. Create view playground reviews demo JSON. Yes. Boom. So now we have also this one that has the same results of, no, not this one, of this one. Okay. Yeah. Not really the same because of the speed I worked on this view, but really the same, very similar, pretty similar results. Okay, the performance are really good. Okay, also the query plan is good in my opinion, and we obtained a result from the consumer perspective that is a table. Okay, so it can be consumed as a table, that their fields are in the specific formats that can be used in the destination engine, like a BI system. And this is my preferred approach. Okay, well, we saw some SQL functions. So the first one, we didn't saw it, just a simple check. So you pass in the argument the field, and it returns 1 or 0 bit if it's JSON or not. Very simple. JSON value returns the scalar. JSON query returns the raw object of a path, a JSON path. And OpenJSON takes a JSON document and perform a projection of each array item into a data row, a table row. Okay. Now let's have some fun. A provocative approach to this NoSQL into SQL Server. Okay, it's something that I'm not using in production, but just to make some experiments. Okay, with JSON. Let's stretch this approach to the max by having a table for everything that can be just ID value. Okay, so let's take inspiration from a NoSQL that is key value, like like Redis, for instance, something like that, and just use an ID that can be generated. So in that case, the table is very simple. So ID just a primary key int identity, and the document is the JSON itself. Okay, in that approach, we have, so let's code select just ID from playground key value, not all the even the doc field, because it would fetch from the database a gigabyte of the document, but just take the IDs. We have 2 documents. Okay, trust me, I tell you that in the first one, there's the document of the movies, and in the second one, the document of the reviews. So in the first one, like 10 megabytes, and in the second one, like 1 gigabyte. Okay, so we can have a nightmare solution that works. Really not the best as it can, but it works. That does this approach. Okay, take the row with the movies, cross-apply all the items into some rows, and perform the projection like we did. At the same time, take the row 4 for the reviews, project them, and perform a join. Okay. This is not the ideal approach, and if you run this stuff, it's hanging for some seconds or minute. Let's use 10 just to be faster. Okay, it works from the specification perspective, so it's producing a result that is consistent, but the query plan tells us here that is materializing all the stuff in 10db into temporary storage in memories and something like that before the join operation. So it's very, very huge and complex operation. But I wanted to show you this approach because you can be so strict, so no SQL, and do something like that by using just a key value store inside SQL Server. Okay, not in this case. So the last topic of today is the next step. So we have JSON, but after some period, after some months, some years, probably we want to free some space that JSON is still occupying, because the JSON format is text. So we can compress, we have some techniques to compress the space occupied by the JSON itself, but they are just not really workarounds, but it's not so easy to do that. So at the point of time, at a specific point in time, you will want to erase some data, or better, to transport, to move that data into some permanent storage that is not JSON anymore. What I want to do with that? I want to do that, in my experience, this JSON approach is very good for operational data that is moving in this period. So in the last X months, years, and the next X months or years. But in outside this boundary, it's better to move out from JSON and to put the data somewhere else. So in my opinion, you can denormalize that data into destination tables that can be optimized themselves without JSON anymore. So how to do that? Let's keep some samples. So let's start from this one. This is the view we just created, full JSON. So let me see, let me check just to be sure. Yes, good. Okay. And let's say we want to produce a table that is reviews all heap. Why heap? Because if I create a table at runtime on the fly during a select, it creates this table with a structure result from this view. And since there's no primary key, and no clustered index by default into this newly created table that it doesn't exist yet. Okay. This will be created as a heap. A heap is a table without a clustered index. So to know in details what a clustered index is, we should have another session about this, but let's just take one row into that. No, top one start. Okay, let's take the table here. Okay, all the fields have been inferred in terms of type, data type, and the row is here. So we can also perform some sort of bulk insert by using some tricks. So from here, now that the table has been created, we can invert the stuff by calling insert into playground reviews all heap with tab lock. Why I often use this this feature? Because when you use the insert into, a log entry is wrote for each insert, but with the tab lock we can avoid a huge log traffic, log workload, so it's quite faster, and it also takes a fraction of the log space compared to the insert into without this part. Of course, the result is that you are locking the table. Okay, so this table cannot be used until we finish this operation. So let's take all the stuff like alpha million rows, and let's wait some seconds. No, well, probably this will take minutes, not seconds, but we can see some progress into this view. that we'll see the size increase. Okay, now we are at a good point, of course. Okay, so we can just wait a second. In the meantime, we can do a performance optimization. So if you ever heard the concept of column store index, the column store is a way to store the table by using indexes on columns instead, by store the columns instead to store the rows. This approach is very effective for aggregation, for data analysis, and also by using this approach, the underlying engine of SQL Server can perform a huge compression on data. So I told you that the heap is not really performant itself because it hasn't a clustered index. So for some situation, from some operation, it's not really performant. But we can create another table with a create clustered column store index that we call this. No, we can call with like the table name, and on this table, okay. And now we have two tables that seems equal, but one has a clustered column store index, and one is just a heap. Okay. In the meantime, let's see if we have the results. Yeah. Okay. The reviews all heap has now 500,000 rows with the 3 GB of space consumed. So this query did good. And now we do the same with the clustered column store index. Boom. There's a huge of content behind the scenes of the column store indexes, so we can discuss them in a session like this, but I'm just telling you some insights. Under the hood, it takes several rows, like 100,000 of rows, and each we say 100,000 of rows. The SQL Server engine compress them into like a block, okay? And when it performs the compression, of course, it reduces the size of the underlying storage of like 10 pair of impact, okay? So what I'm expecting to see, I'm expecting to see here that the resulting CCI table will host the same number of rows, but with a fraction of price, so of a fraction of size. In addition to this, the heap hasn't a clustered index, hasn't indexes, okay? So if we make a query, like select the average this rating, okay, some seconds, okay, like 1 second, okay, and the query plan is this one, okay, let's see here. While in the other one, I'm having some confusion right here, so just a second, let's see if it finished. Not yet. It's slower to run the insert in the CCI table instead the heap one, because while it's inserting, it's compressing the pages, not really the pages, the group of rows, and it's quite slower. But after that, we have a result that is really impressive. So let's wait just a few seconds. In the meantime, if there are some questions, I'm happy to reply. Okay, I see. No, just a comment. Thank Mike. Okay, let's see. Well, to avoid to wait, we should wait about another minute or two. We have another one that is ready. Okay. In this case, you see that the impact in terms of size is very different. So half a gigabyte compared to 3 gigabytes for the same exact data. And if we perform the aggregation, so the average in that case, since the data is organized into columns, the query plan is completely different, and the query performance is like a fraction of a second. Okay. Good. This is my favorite approach when the JSON is not needed anymore and we want to make some history tables or some tables that are not so changing anymore from the outside. So when the JSON coming from outside are quite quite frozen. Okay. So to make a recap of this session, my personal opinion is that relational is just great, is amazing, and stays, of course. And for the most of workloads, I prefer to have tables that keep some transactional data. I also told you at the beginning of the session that I came from an experience when we used NoSQL for the 99% of our applications. So I'm not telling that is a bad approach. No, the opposite. I want integration. I want to integrate the two words of relational and NoSQL. But I also wanted to mix inside the SQL server itself also some NoSQL notions like the JSON function that we discussed in this session. I also told you that you can think in the longer term with the normalizing those data sets and compress them to gain performance. And of course, we can have indexes into the JSON properties. We didn't see in this session, but I told you that when the JSON document is a simple root document without, it's not an array in short, you can also create an index on a single specific property of the JSON. And the underlying SQL Server engine will apply the same exact characteristics of the index of another kind of field that is materialized, that is plain old field of SQL Server. So I thank you very much. This stuff is on GitHub, on my profile on GitHub. All the code, the presentation, the database project, the C# to fill the data. The only thing that is not in the Git repo is the dataset because it's 1 gigabyte of data, but there's a link to download it and test by yourself. I thank you very much to be here, and if you have any question, I'm here. Good. Thanks a lot, folks, and have a great session ahead. Bye.